25. We have fractions, divide fraction here. We have a bracket, which is the result first, then the divide fraction. Then, but the result of this, the quotient of this adds to 1/8 within the bracket. And I don't know, if you don't know, that of is represented by a multiplication sign. So we end up with 2/3 of open bracket 1/8 plus 5/12. Don't really leave this first fraction in a division, not trouble it. We don't really leave it. We change the divide sign to a multiplication. And what we do, we don't divide fraction, we multiply it by its reciprocal. Reciprocal simply means we upturn the second fraction. Only the second fraction is upturned, the second fraction. As a result, you can multiply straight across. But what we normally encourage students to do is do what we call a cancel. If you do your 3 times tables, you have a couple of brackets of 9 and 12 will be 3. 3 into 9 goes 3 times, and 3 to 12 goes 4 times. There's no other, you can have the cancel vertically, but if you have 5 or 4, there's no cancel you can make it out of that. So as a result, we write back these 2/3 of open bracket 1/8. Now the quotient of this 5 times 3 is 15, and 4 times 1 is 4. Based on this now, you can recognize, first of all, you don't add fractions that have different denominators. At some point, you have to make the denominators alike or the same. So, for the timetable, you recognize that the LCM for 4 and 8, the lowest common multiple, the lowest common denominator will be 8. How does 4 become 8? Simple. You double the denominator. Why do the bottom? You do the top. And let's go down 2/3 of open bracket 1/8 plus 30 over 8. When you combine these two, we have 2/3. The sum of these two is 31 over 8. Again, we can find the 8 here because you recognize that 2 and 8 has a relationship. 2 can go itself once and go to 8 4 times. So the result is 1 times 31 is 31, and 3 times 4 is 12. At this point, you have to finish. Some persons like this in the answer as probably a big number. 12 to 31 goes twice 12, 24. 12, and 24, and 24 from 31 is 7 over 12. This is either or. This is not a math. Thank you. What things you look for? You look for SBC square number. We had your list already. I gave you a list in your chat. We know that 7 times 7 is 49. So you have to think this is a square number. Question. Can this be factorized?
No.
Yeah. No. No. What's the difference between this and this? Good. So what's going to plus? No. What about this? Is it the same? For the certain that a square number. So no. What about this here? Yeah. Perfect squares. Difference of squares, yes. What about this? No. This one, for the same other number number. It's not a square number. Can this work? The x and a square. So also, no. Imagine that? So the variable has to always be what? Squares as well. Good. And all these came from the fact that you know, whenever you see a squared minus b squared, you know, it is only a plus b, a minus b. So look at this. So I'm going to come down, please. You do this. What times 1 give 1 9? 7. What times 1 give x squared? X. Good. So following this, the a is here, a, and b is here, plus b minus b. A goes into first one, so x goes on b to first one. You have minus b here, but you have plus a minus b. So you have now plus 7 minus 7. Can it be minus 7 plus 7? It matter? It does not matter. Very good. So it could be the minus first, the plus last, or the plus first, and the minus last. Okay? I want to make sure I understand that. Okay? Good. So that's the answer for the first one. So, because that everything has a reverse. X times X, reverse it. Let's reverse it. Or math check. But watching? X times X is what? X squared. X times negative 7. Negative 7x. Negative 7x. 7 times X. 7x. Plus 7x. Positive. Good. And positive or negative? Negative. 7 times 7. 49. 7 times 7. 49. Good. And then, what happened here? Cancel. You do what? X squared minus 49. So the reverse of this process is to simply follow this. This is A, this is A, yeah. This is B, this is B. How does this become this? X squared is X squared. 7 squared is 49. That means XX position minus 7. It's a simple process. You memorize it. A quadratic equation, when you call trinomial, what is trinomial? 3. What looks like 3 things here? 3 memory things. Variable, well, that's a variable. That's a variable. Terms. Yeah, 3 terms. Okay? Good. So we have 3 terms here. We have a quadratic equation. Now, how does this work? Normally, well, the coefficient of x squared in this case is what? 1. Are you agree? Good. So we have something called the AC method. The AC method, where we look at ax squared plus bx plus c. Looking at this, ax squared plus bx plus c. What number is in the A position? Huh? 1. What is in the B position? 2. And what is in the C position? Negative 35. Okay? So basically, AC method, you are to multiply, that right here, guys, except for John, A times C. Okay? But the good thing about it, because one doesn't change anything, 1 times negative 35, which is 1 times negative 35, see here, the 1 times negative 35 is a what? The negative 35. There are other cases where this will be a 2, a 3, a 4. It could be minus 5. It could be a half. But in this case, it is what? 1. That's the result. When you see this could be 1, you're working the cookie that gets easy. So all I have to do is see me what you have done. You understand? Because the 1 here is going to change up here. If this was a 2, then we're going to be what? Positive, negative 17. You understand? Yeah. Go. The guy is good, yeah? Let's begin. The guy is very good, yeah? Now, to get the negative number, guys, to get negative number, what has to happen in terms of the two factors? Yeah, I can block one here, your left hand.
No.
But from here, you go to left.
Yeah, God. Sorry.
Alright.
Sorry.
For this to be negative, guys, based on the rules of integers, what has to happen?
7 times negative 5.
Huh?
7 times negative 5.
Okay, before you use the numbers there, let's start the rules for multiplication of integers. I'm not denying what you say. What the rules of negative for integers? A negative and negative is that. So that can't be that. So this is a negative. How do I get a negative here? Well, what is the one? And this is the one. We got negative, we got the negative, but then positive and negative. I don't get, I don't think negative. Let's go. Let's go. You get confused, you know. A positive is one. A negative and negative is a. So that one of these factors have to be what? Thank you. That's what you put these. Yeah. So at some point, one of the factors have to be negative. So let's go. The factors of 35. 1 and 35. Let me start over here. 1 and 35. You write it twice because 1 has to be negative. The other have to be positive. Okay? So it could either be negative 1 times 35 or 1 times negative 35. The thing is though, when you add or subtract these numbers, you must end up with the middle term. The middle term is what? 2. That's the goal again. The 2, right? Understand? So these two can't work. One of the factors, you mentioned some. 5 and 7. Write it twice. Why am I writing it twice? Good. So in this case, there's the 5, positive 7, or positive 5, negative 7. Any of these can give you 2. 7 take away 5. 2. And 5 take away 7.
Negative.
Good. 1 take away 35 is negative 34. And 35 take away 1 is 34. Only one gave me positive 2. So the factors here are minus 5 and 7. With that occurrence, start writing with you guys. You simply put x. You know what to do the language first? I'm doing the language first. I'm writing back over. X squared plus 2x minus 35. X squared, in this case, minus 5x plus 7x minus 35. Am I saying it here? I can't do it. Look at it. This is this. Would you agree?
Yes.
7 take away 5 is what? Again, let's go back. 7 take away 5 is What do you 7 comes from?
It's a factor.
One of the factors. Minus 5 as well. So what they're saying, these are two factors were originally used to get that. You understand? To get you to sell it. Based on that now, you group these, you group them, you factor again. What is common to both sides? Quickly. X. Leave it at what? X. Take away 5. Let's look over here. What's common to both sides? Positive 7. 7 times 1 gives 7x.
1.
X. 7 times 1 gives negative 35.
Negative.
Ah, now you're kidding me. 7 times negative 5 gives negative 25.
Yes.
So 7 times 1 gives negative 35. That's change. Right. That's not 5.
Negative.
Negative 5. This comes down. X plus 7 and x minus 5. Okay? You write this once and you put these together. The reason for that is that you are factorizing again. I could teach you that as well, but it's going to take us some time. Okay? Okay. Let me know to make explain this. To put in the camera. I'll explain. Alright? Pretend this is A. Let's call this one. B. No, let's call it B. Let's call this plus C. That means that the tallest one. Like, what let's call that. And X minus 5 over here is called B. What can you call over here? B. It's the same thing, B. What is common to both sides?
B.
B, right? Yeah. So B is common to both sides. So if B is common to both sides, we put B, leave it back in what?
A.
A plus C. Let's do substitute now. What was B again?
X minus 5.
X minus 5. What's A? A is X. What is C? Positive 7. You want to see that? As you know, we have here difference of squares, the difference of two squares. You can tell by the minus sign difference. You can tell by the formula being the square number, 7 times 7, and the x being squared. The result of that is x minus 7x plus 7. We found this the last video as well, the last time. We found this to be quickly x minus 7, x minus 5. As you can tell, when you look at the top, the numerator and the bottom, the denominator, recognize that they both have this. This is the 7 goes ones, x minus 7 is 7 goes ones. Leaves you with x plus 7 over x minus 5. Alright? Good. Finish. factor for this, you get along with the AC method. So the AC method is AC method. What the A came from? Who could tell me? Quickly. The A to this one, you see good. But mathematically is A is the coefficient of x squared and the C is the constant in the end. Constant is something that don't have no variable in it. You see, it's just multiply when you have the x. Right? Good. The shortcut is this. Again, back to what we're saying. Because this is 1, it doesn't change the negative 1. 1 negative is minus 1. 1 negative is minus 1 good. So basically, all the thing that you do, it was watch the back plan. So that's what we do for this one. Because the coefficient is 1 here, the coefficient is 1 as well. So all of you do is watch the back plan. Okay? The factors for negative 35, you recognize what? 5 and 5 and 7 is 35. Which one will be negative? We don't know yet. Which one will be positive? We don't know. But when you add or subtract, this gave us what? 2. Right? 7 equal 5 is 2, right? You go from plus something into 1, and the 1 that help your eyes. 7 equal 5 is 2. Or 5 equal 7 is 1. Good. So this was the one that was chosen. Alright, and we thought of this being chosen because its coefficient is 1. Look here. You put x here, you put x here, you put positive 7 in here, and you put minus 5 1. You see that? Yeah. That's the sharp. You see that? Yeah. So the shortcut is find the factors of what? Negative 30. See which one gives you what? Positive 2. And then you simply split them in. The x goes first, the minus 1 plus 7 goes down. Okay, like that? So we're going to save them over here. Should we make them what we go to 1 times 8? Because what? 1 times 8 is to be what? A. The factors of A. This is positive, right? Yeah. So we have to write it twice, then go over here. Because both factors. Well, sorry, I think what? Now, because today is clear positive too. I forget about that. So let me get that say that way. Let's go. And if I do okay, quickly. 7 smallest. 1 times. Or there is 1 times negative A. Then what? 2 times 4 or times 4. Am I there? Good. Quick, let's go on. Now, if it doesn't work, if this is a plus, then you're not the one with it. But you don't, you guys say too familiar with that. If it's here plus here, then generally it will always be positive. Right? But suppose you don't know that. But I still put it into negative. 2 times is not negative. Good. Which of these can give me positive 6? Let's see. Let's give me one. Positive 9. Good. Let's give me one. Good. Let's give me one. Positive 6. And let's give me a. So the factors are what? Positive 2, positive 4. See, that's positive 2, positive 4. So let's go down. With the x number. Here, here, positive 2, positive 4. When the coefficient is 1, that's all you have to do. You see me again? When the coefficient of x squared equals 1, you have to do the shortcut. Yes. Yes. You know, it's when you go to another pole, and the coefficient is 1. Good. Well, but look at this one now. What factors are we looking for? We take factor for. The factor of 12. But x squared by 12 minus 1 plus 1. 12. plus what? 6 x minus 12, right? What? So when the factors down, that's the 12. Negative 12. That's all. The factors of negative 12. Let's go. 1 times negative 1 times 12. 2 times the 2 times negative 6. Negative 2 times 6. And what else? That's something I got something on them. Yeah, sport X here.
Yeah.
Yeah, but I want over the 12, so everyone's saying yes. But the thing is, this is because they have 6x here, but they have 4x here. Let me go again. This is what? 4. So you get the question that a mistake, okay? So this will be 4. So which of these could give you 4? Can you give 4? Just give you 1. Tell me.
Negative 11.
Negative 11. Just give you 11. Just give you negative 4. Just give you 4. Just give you negative 1. Just give you 1. So which one is going to give you 4?
Negative 2.
Good. So when you back down, we're going to have a good guys. X squared. Yeah, oh yeah, well, open bracket, sorry. Yes, thank you. X, X. What the fuck is that?
Negative 2 and 6.
Plus 6. Imagine that? Good. Case, the coefficient is not 1 anymore. It is now 1. 2. So you just say, what's this? But why not? But why not do this? You don't know what it is. Multiply by 2. You gotta double it then. Imagine that? Money. You realize? Which will give us what, class? That is 12. Guys, stop calling numbers of the side. If you're still doing that, that means you're still in kindergarten. To the tell this is that 12. 12 is above 0. Then this 12 is below 0. Don't make those mistakes. And if you make a mistake, you are not trapped to not pass maths. The mistake is supposed to overcome. Okay? We have negative 12. What two factors of negative 12 now? Let's have the factors of it. You know, the 0 key. Can 1 and 12 you a 1?
Yeah.
No, 1 from 12 or 12 from 1 can you negative 1. You can move on from there. What are the two factors of 3 and 4? 3 and 4. Good. Right, so let's try 3 and 4. Make one positive, make the other negative. Which of these can give me negative 1? Just give me 1. Yeah, the second one. So just give me 1. 1. Just give me
Negative 1.
negative 1. So now in this case, you just can show me the answer. Why? Because the coefficient was not 1.
Yeah, it's
So
2.
what do you do now? Start writing. You write back into x squared. Then you take this, and put 1 plus 3x minus 4x minus 6. Then you look at that group, you look at that group. What's common to this? What's common to both sides? Huh? The x, or the x common. How do I get x to come to x squared? X, that's what gets x squared. X is the part of it, but what do you do? Except x is x squared, but where the 2 coming from? No, that's adding and multiplying. Times 2. Let's put in a 2. So 2x x is 2x squared. Okay? X times 1 gives 3x. plus 3. Remember, what's about this? What's about this? We will add. It then a reverse. It repeats. Remember that? So what will happen? You simply what? Put it back. And now let's say, what times positive to x is negative 4x? What times positive 2 is negative 4, guys? Negative 2. The x is already there. Okay? Let's not check out negative 2, then positive 3, and then the positive is that
Negative.
2 times 3,
6.
that. So this now the what? Tell you guys? Repeats. So that's all of this findings. Then, follow the arrow line. X minus 2. And they go into the same way, You write these ones, and you join with these two. I'll show you the reason for that earlier, okay? Okay, you factorize it as well.
That's it?
Yeah. Right, the first way for this, we are going to transpose, which means make M the subject. Alright, we'll make M the subject. Alright. Now we have a chance here. We're going to take this, I'm going to carry it over. So we end up with positive M squared plus the S is positive X. You just simply attach the plus now, because the S is always positive. This one negative becomes positive, but you don't start off the equation with a plus sign. You can start with a negative sign, but you don't start with a plus sign. The K remains the same. Okay? Then what we do, we carry over the S. The same positive S, M squared remains equals K take away X. Now what they're saying here, what times what? What times what they get given that? So you get it square. But that square, the opposite of it is square root. So M equals the square root of K minus X. Once you reach here, we are finished. Another way, a quicker way I would assume is if you simply move the N square and the X one time. You bring over the X, while it's bringing over the M on the other side. We're crossing the equal sign each time. So this now becomes positive. The K remains the same. The S becomes negative. As you can tell, we're at that stage. And then you simply N equals the square root of K minus X. I prefer this way to move them one time. Okay? Next question is question C. It's a bit of a narrative, but listen up carefully. Lisa has $56 to buy a total of no more than 70 red balloons and green balloons for her party. So she buys more green balloons than red balloons, but must buy at least 15 red balloons. Each red balloon costs 75 cents, And each green balloon costs 50 cents. Let X and Y represent the number of red balloons and the number of green balloons respectively. Write two inequalities in X and Y other than X is greater than or equal to 0 and Y is greater than or equal to 0 to represent the information above. As they say, let X be red balloons and let Y be green balloons. It was saying from the first question, Lisa has $56 to buy a total of no more than 70 red balloons and green balloons for her party. Well, if X is red balloons and Y is green balloons, X plus Y, the red and the green balloons, can be no more than, what is it? 70 balloons. That's how you put no more than, because they have to be less than 70, but it can also equal to 70. But it can't exceed or surpass or go beyond 70. So the symbol you use, the inequality you use is this. So you add red and green balloons, you get less than or equal to 70. That's one equation. The next equation you would get is that she buys more green balloons than red balloons, but must buy at least 15 red balloons. Each red balloon costs 75 cents, and each green balloon costs 50 cents. When the first person that says she buys more green balloons than red balloons, that means she buys more green balloons than red balloons. So green balloons must be greater than red balloons. Green balloons must be greater. The opening means greater, the point means less than. So the red balloon must be less than the green balloon. The green balloon must be greater. Right? We have a situation we said down. She buys more green balloons than red balloons. So we have balloons, red, we have green. The green balloons are more than the red balloons. The opening suggests that if this is greater, the back pad or the point pad, the rear end here, represents left pad. So less red balloons than green balloons, more green balloons than red balloons. The third equation that can come about is that it said that each red balloon costs 75 cents. So 75 cents for red balloons and plus 50 cents for each 50 cents for each green balloons. When that adds up, we don't know how much money when green balloons and not red balloons. When they add up, they all add up to $56 from the original question. Another one that can come out as well, they said that X and Y is the number of red balloons and I missed somewhere. Oh yes, that's right. But she buys more green balloons than red balloons, but must buy at least 15 red balloons. Another equation saying you must buy at least 15 red balloons. So red balloons must be more or equal to 50. You can't have less. You can't have it the other way. The red balloons can be less than 50. It has to be greater. Understand that must buy at least 15 tons. And at least 15 may have to be 16, 17, 18, 19, 20 X. Red balloons must be more than 15. inverse proportion. Inverse proportion. Inverse proportion is y equals k over x. This k represents like a scale factor percent. Okay? Question says, given that y is inversely proportional to x minus 2. So if x is proportional, inverse proportional to y, but let's say inverse proportional to x minus 2, you substitute the x minus 2. You simply write back the y equals the k, but whatever x is, you now have to shift it to what the question says. Because the normal formula would have y versus the x in an inverse relationship. The inverse relationship will look like that. Okay? Where if x is increased, no, let's say that next something like this. If x is increased to here, the y drops to here. That's how inverse relationship goes. I give a good example. If 10 men takes 5 days to build a house, 5 men should take at least 10 days. In other words, if I decrease the men, they must take longer. Or if I decrease the if I increase the men, the time should be shorter. Because more men should be that you do the work quicker. Okay? But the thing is, this x has to now change to x minus 2 based on the question saying, given that y is inversely proportional to x minus 2. Good. Now, bear that in mind, that's the new formula. You substitute. You say x is 11, x equals 11, and y equals 9. Oh, no. Yes, when x is 11, y equals 9. Sorry. So you substitute. And when you do this, you try to find the scale pattern. We try different math. Let me continue with that. Okay? So y equals 9. K remains the same. We don't know what that factor is. X is 11 minus 2. This is simple math. 11 minus 2 is what, 9? Good. That's something right here. Okay, yeah, very good, yeah. And then to get the 9 from all the here, you divide by 9, it goes over, it comes times 9. So K basically is 81. Now based on that, it says find the value of y when x is 29. We write back the formula y equals k x minus 2. We now know what k is. We know that k is now 81. We know it gave you an x. They say when x is 29. So 29 take away 2. Find out what will y be. Again, the simple math. 81 divided by 27. I know it's the tables, and I know that 27 I'm going to 81 3 times. I can see. 3 sevens are 21, 3 twos are 6, 7, 8. So I know then that 27 into 7 goes 1 into 81 3 times. So y is equal to 3. It's still about this in that you have to find out What is the inverse proportion, which is probably that. The regular proportion is really y equals kx. This is direct proportion. Proportion. But inverse is divide. And then whenever they give us an x, then now they change that formula. You simply substitute x for the actual thing they give you in the question. And that'll be it. So as a can you later about why it's three? Thank you. Notice that 4 times 4 is 16. This area here is 4, this is 3, so this becomes what? 12. Okay? This is 4. This is how much? So this will also be 12. This is 3, and this is 3. What is that be? 9. 3 times 3, 9. What's that? What's the total we have here though? Let's know. Is it what? No. 12 times 12. 12 plus 12 is 24. 24 plus 16 is 40. 40 there. Very good. So the area of the land, the total area is 49. Okay? Whatever the units of measurement is. Now, bear in mind, remember Joel land was 16. It now increased to what? 49. So let's look at it this way now. 4 plus the 3. 4 plus, yeah, but 4 plus 3 squared, which gives us 4 plus 3. 4 plus 3. What's that? What we're doing now, we're going to process called, what do you call that? FOIL. What is FOIL stands for? Very good. So first, outer, inner, last. First with first. Outer. The two inner ones. Inner. And the two last ones. Okay? Another way you can write this is 4 times this 4 times all of this, and then plus 3 times all of that. Imagine that. You take the 4, you multiply by all of that, you take the plus 3, multiply by all of that. It's still the same thing. First, outer 4 times 3, 4 times 3, outer. Inner 3 times 4, 3 times 4. Last 3 times 3, 3 times 3. Okay? So let's go. 4 times 4 is what? 16. 4 times 3. 3 times 4. And 3 times 3. Those numbers don't come in here. Look at the graph. The square. What shape is this? A square. What are we doing? Perfect what? Squares. Let's look at the number 49 now. 1 squared. 1 times 1. I want to hear about it. 1 times 1. 2 squared. 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. So, you see that? 16 is a square number. 9 is a square number. 49 is a square number. So the square number appears here and here. Okay? And generally, these here, we add them together. So this is 24, and the total of here what? 49, which is also a square number. So the square number appears on the outer ones, and if you actually put in numbers, you should be able to get a square number, because you are working out a square and finding the length of the length of a square. But after that, the numbers we are using 4 or 3. The 4 and 3 is to give you a context where all of this came from. So say we say A general case will be 4 and the extra piece of land will be 3. Remember, you're gonna increase it to more, to be 6, to be less, to whatever. We don't care. The point is using arbitrary letters. It could be X and Y as well. But we use the A and B. So A plus B goes back to square. You say A plus B then A plus B. Based on foil, goes out of inner lines. A times A plus A squared. A times B
Well, no, A,
plus AB. B times A.
B,
We have to ask for the line.
A, B,
A to C. B A and A to C. Let's put it out to the line. B times B. B squared. Good. So based on that, if I give you A minus B squared now, A minus B goes back to A minus B. Remember, it could be like this now. Instead, I'm going to put it over here. I'm going to put it over here. Right. Instead of Joel wanting to increase the land, Joel could have had a big piece of land and said, "Man, this is what plan to work." So what she did, all of that is A, all of that is A. Joel said, "Boss, I think was about land, you put it down." But you have to put it down into what size? Look at me.
what?
A square. Remember, we did with square, perfect squares. So she said, "You know what? Take off B from here. Take off B from here. Leave me back. This will be A take away B. For example, this is 10, and this is take away 3. 10 take away 3 will be what? How many here? 7. So 10 take away 3 will give you 7, okay? Over here as well will be A take away B. So the A take away thing now, the land will now be reduced to just this size. So it was small, it increased to 49.16, but this came down, she reduced it instead. So how can this go? Let's go A times A is A squared. A times negative B, negative A B, negative B times A, negative A B, Negative B times negative B. Negative negative that.
Positive.
So A squared minus AB minus AB. You want to miss an amp machine, you're missing another amp machine. You're missing an amp machine, you're missing an amp machine. What's the answer?
You're missing 12 machines. Negative 2.
Minus 1, minus 1.
No, AB, just AB.
No. You're missing an amp machine and you're missing another amp machine. How much you missing? You're missing 2
AB, I don't know.
amp machine.
But you're going to add them there.
You keep going down. You keep missing. So you never one of us say, oh, I'm missing amp machine, this amp machine. You say you're missing how much? 2. Everybody agree? Or you're all amp machine, you're all another amp machine. What's your off? You're off 2 amp machine. You understand? So look at this now. Oh, man, let me finish on this one. So look at this one, sorry. Up here, A squared plus 2AB plus B squared. You realize something here? Look at the middle one. Remember we added these two? Everybody remember that? The two middle ones always add to give you this. Okay? So look at this. These two. So this is positive 2AB. This is 1.
Negative to AB.
And everybody to me, please. Mali. I'll tell you a couple of goals, Mali. This is what? Positive.
To AB.
Everybody positive.
To AB.
This is what? Negative.
To AB.
So it's this plus here, we get positive 2AB. And it's negative B, then with negative 2AB. Okay? Now, what about if Joel had a piece of land, the same square, but watch it? The same square. But this time, Joel says she wanted the land, okay. She wanted the land in piece going this direction. But watch it?
Yeah.
So she wants that extra piece on, but over here is A as well. But we put it in other clubs, sorry. But she wants so much land going down. She wanted the land across her, but she wanted to take off some from the bottom. So the land now looks like this. Everybody see that? She added on a piece that way, but she took off some from the bottom. And she took off the same amount from the bottom. She took off, she took off B. So this down here becomes what? A minus B. Look at a different color. This becomes A minus B. And up here becomes A plus B. So this time the line was reduced to this square here. But this one it was reduced percent. We changed the shape from what? A square to a rectangle. Called it, we added on B to the right, but we took off some from the sum. So end up with this now. A plus B, A minus B. This is what we call difference. That write it up to be except for the cameraman. The difference of two squares. So there are two perfect squares, there are two types of perfect squares, and then the last one is a difference where one is plus B and the other is what? Minus B. Imagine that? One is plus B, which is plus B plus B. This one is minus B, which is what? Minus B minus B. But this one is plus B, and the other is what? minus B. Bear in mind, you could switch them around and still the same answer. What do you mean by switch them around? Who can tell me?
Like, if the minus all the other so
Tell it now.
A minus B and then A plus B.
Good. So you'll get the same answer still. Let's see what we get. A times A, we will do 5. A times A, A squared. Good. A times B, positive AB, good. Then we need B times A. Negative A, B. And B, negative B times positive B. And negative on the positive.
B.
Negative on the positive. Negative B. Squared, son. So now what is happening here? Come on, cameraman. We have an add machine plus an add machine give us two add machine. This one we power the add machine, we power another add machine, so we offer bunch. Two. But look over here. We have one, but we all one. What happens here, guys? What happens if you have something but you still got somebody the same thing? You have a toaster, but you borrowed somebody toaster before and you get it back. But you have your ego. What are you supposed to do?
Give him 4 so you get 0.
Huh?
You ain't gonna
You know not done. Because if the person want back the toaster on the air machine and you have one, but if you borrow somebody one, you don't know where you put it. But you buy one yourself, what will happen? You have to get them yours. They're called common sense law.
Yeah.
That means you left with what? Nothing. So now as a result of that, because we left with nothing, this now becomes what? A squared minus B squared. That's that? So what's really in the middle? What's really in the middle is what? A squared plus 0AB minus B squared. But we ain't going to 0AB. You can't worry about it. But I said, 0AB means you're wasting your A. So if nothing is there, you simply join it up.